How's it going, everybody? Thanks for tuning in. We're going to do probability 2 notes here. But before we do, back by popular demand, I have my daughter, Cora, who is going to lead us off with another joke.
Why did the school take you the homework? Because the teacher said it was a piece of cake.
All right. Good job. All right. I know some people have said that April Fool's Day needs to be canceled because nothing from April Fool's Day could be nearly as crazy as what we're dealing with. I don't know about that, but starting with a joke never hurt anyone. So anyway, again, that was backed by popular demand. So hopefully it gets us off to a good start. Now, before we get going here, I want to make sure you know why we're doing probability. It doesn't really seem like a geometry concept. And it is and it isn't. I could show you how it relates to geometry. In fact, we'll get there toward the end. But really, to be completely honest, it's just something that the algebra teachers think that the geometry teachers are going to do. And it's something the geometry teachers think the algebra teachers are going to do. And then when it's all said and done, nobody knows what's going on, and it doesn't get done. So we're doing it here, and I think it will help us out. So when we get started here with this lesson, it says to think about a row of 5 students, and you want to choose 2 to be in a group. How many different groups can we make? So in the previous lesson, we learned that you can take blanks, and you can say, well, I am going to have 5 students to choose from. Let's say I have 5 different students here. I have a row of 5. So we're pretending we're in the building here, and there are 5 students. Well, I could choose any of the 5 to be in my group. But as soon as I have chosen someone, now I only have 4 choices left. So in the previous lesson, we would have said 20. Today, we're learning something slightly different. It's only a little bit different, but it's going to have a huge impact on how we do these problems. Sometimes that method does not work, and I'm going to prove it to you. Let's say we have 5 students, and we're going to label them A, B, C, D, and E. Okay? So let's make groups here. A, B, let's say student A and student B are in a group. Then AC or AD or AE. Okay, so that covers all the different ways that student A could be in a group. And then we could do BC, BD, BE. Then we could do CD, CE. And then last but not least, DE. So if we were making groups of 2, we would find out that the correct answer, how many different groups can we make? The correct answer is 10. But that's really weird because in lesson number 1, the answer would have been 20. So what's the difference? Why do we have to do it differently today? The key is, if I put, let's say, Bob and Chris, I'm just thinking letters here like B and C. If I put Bob and Chris in a group of 2, isn't that the same as putting Chris and Bob in a group of 2? If I make a group and it has Bob and Chris in it, isn't that the same as if I did a group with Chris and Bob in it? You see, there are times in real life where order matters, but then there are also real life situations where order doesn't matter. And when that happens, then we're going to use a different method. We're going to use what are called combinations instead of permutations. Now, some of you have gotten to the point, I don't know if it's out of laziness, you don't want to do the work anymore, and so you're trying to figure out how the calculator will do it. And you may have noticed that your calculator has both an NPR button and an NCR button. The first lesson we learned permutations. Today we are learning combinations. So that's the difference. There are two different types of situation that we have to consider. Okay? So let's talk about situations that use permutations here. Okay, now sometimes they're actually going to use the word order. When order matters, how many different orders can you arrange the books in? That sort of thing. That's a great one. Now another one would be lineups. If you're thinking about a starting lineup for a baseball team, the key to that one, the reason why it's important, is you want your best batters batting in a certain place in the lineup. You usually want your worst batter hitting last because you want that person to come up to bat fewer times. So in a lineup, order matters. I'm not going to take my best player and bat my best player 8th in the batting lineup. I'm going to bat them in one of the first 3 to 4 spots because I want them to get as many chances as they can get. Okay, so that's another situation where order matters. Now, one other example, and these aren't the only ones. I just want to give people ideas of key words that they can be using to identify when to do what. Whenever you're talking about awards, something like medals or trophies or places, that sort of thing. If I am in a contest, I want to finish first. I don't want to finish second. So there's a difference between finishing first and finishing second. If I'm just in a contest where, let's say, the top 3, get to move on to the next round, well, obviously then order wouldn't matter. So, situations that use permutations, anything that involves orders, lineups, awards, medals, places, that sort of thing, that is when you're going to use a permutation, okay? On your calculator, it would be NPR. Also, there's a formula to it that we practiced as well. Okay, let's talk about when would we use combinations instead. And that's what we're going to do today, and we're going to practice that. This would be more for if you're making groups. Order doesn't matter. If I say make a group of 3, it's not like there's first place, second place, third place. It's just a group of 3. All right. Now, whenever we talk about politics or something like that, you would have, let's say, committees or councils, something like that. That would be another great example of a situation that uses a combination instead of a permutation. Now, another example, this might surprise you, but something like Powerball, something like a lottery, is oftentimes a combination. Because in Powerball, they give you 5 white numbers, and then they give you a red number. In order to win the prize, you have to guess them all correctly, but the order of the white balls does not matter. So that part of it is actually a combination. And we're going to do the Powerball question here a little bit later because I think it's an important question. I think people need to learn how to figure out how many different ways things can be done so that they realize that, oh, wow, I did not realize that I had such a bad chance of winning. Maybe I shouldn't spend the money. I'm not judging people who play the lottery. I've played the lottery before. But I'm just saying the odds are not in your favor. Anyway, so we are going to try these problems using 2 methods. We're going to do the blanks method that I taught you before for permutations with one little difference. And then we are also going to actually practice the formula. All right, so a group of 3 people is being formed from 6 candidates. How many ways can this occur? Now, I want you to think about what we did when we did permutations. We said, hey, there are 6 people who could be chosen. As soon as somebody is chosen, now there are 5 people left, and then 4. When we did permutations, we were done. That was all we had to do. In combinations, and remember, this is definitely a combination because it is dealing with a group of 3 people, we have to do a special add-on to make it right. Combinations are going to involve fewer possibilities because you have to divide out all the repeated answers. Think about our example from earlier. In a permutation, these would count as 2 separate choices. In a combination, these only count as 1, so you have to divide out all the repeats. The way to do that, I jokingly call it the combination count up. You just literally start at the number 1, and then you count up. Turn it into a fraction. That's all you got to do. So 6 times 5 times 4 is 120. 1 times 2 times 3 is 6, and then you just divide. And the answer would be 20 ways. Okay. I want to practice the combination count up a couple different times here, and then I'll go to the formula. Okay, so we're actually going to go to number 3, then I'll show you how the formula works. 15 people are running to be a part of the special city council, but only 3 will be chosen to be a part of the group. How many different ways can the city council be decided? Okay, so we're going to do the same thing. We're going to do, and this number is going to be a little bit bigger. We're going to say there are 15 choices for city council. As soon as somebody makes it, there are only 14 left, and then 13. But it's just a city council. I didn't say president, vice president, yada, yada, yada. So that means we have to do the combination count up. The key word here was like council. Okay, that's how I knew it was going to be a combination. All right, now, in this case, the numbers are going to get pretty big, so a calculator would probably not hurt. All right, so you get 15 times 14 times 13 would be 2,730. But we are going to divide that number by 6 because, again, we are dividing out all the repeats. This is a combination, not a permutation, and you would end up getting 455 ways that you could make a city council. All right, before we keep going, I want to teach you the formula here. Okay, so for question number 2, let's say you wanted to do question number 2, but you wanted to use the formula. This would be a 6C3. I have 6 people to choose from, and I have 3 I am choosing. So the setup is actually exactly the same way that we did with permutations. The formula is actually almost exactly the same as well. The only difference is there is an extra R at the end. Okay? So the way it would be set up is something like this. All right, so you clean that up. 6 minus 3 is 3. So you would get 6 factorial on top. And then on bottom, you would actually get, like I said, 6 minus 3 is 3. And then you would have 2 of those because in the combinations formula, there is a second one. All right. So what you would end up getting here (6 factorial) 6 times 5 times 4 times 3 times 2 times 1 is 720. Then 3 factorial, 3 times 2 times 1 is 6. And then we would have another 6. Okay? So when you multiply those together, you would end up getting 720 over 36. And I don't think it will surprise you very much to know that 720 divided by 36 is 20 ways. Okay. So you get the exact same answer no matter what you do. All right. Now, I'm going to show you another concept here that you can apply to these. When you do problem number 3, I don't know if you noticed this, but if you were to try the formula, it would be a 15C3, which is just absolutely insane. What in the world are we doing with a 15C3? You've got 15 people to choose from, and you're only going to choose 3. My word, that's crazy. So what do? Well, I want to throw something out there. It's kind of a time saver. If you have a calculator that does a 15C3 without trying to get cute like this, that's great. But I just want to bring up a concept of what's going on here. 15 factorial would be 15 times 14 times 13 times 12 times 11, ... Now look on bottom. 15 minus 3 is 12. So 12 factorial would be 12 times 11 times 10 times 9, ... And then you would have to do another 3 factorial at the end, okay? Now, I don't know about you, but that's about the point where you just look and you're like, yep, I'm done. This is stupid. What the heck is going on? Take a look. 12 factorial is 12 times 11 times 10 times 9, ... If you look up there, isn't there already a 12 times 11 times 10 times 9, ... When you have a fraction and you multiply and divide by the same number, you've got the same number in the numerator as you do in the denominator. They really just cancel out. So all you really have here, after everything cancels out and everything settles down, is 15 times 14 times 13 on top, and then 3 factorial, which is 3 times 2 times 1 on bottom, which I don't know if you've noticed this, that is exactly what we had over here. So when I teach you how to do these problems using blanks, I'm showing it to you that way because it is the same as the formula. I just think it looks a little bit cleaner. I just think it looks a little bit better when it's all said and done. So anyway, no matter how you do it, you're still going to get 455 ways of choosing the special city council. Okay. All right, let's move on here. We're going to do a few more together. I'm actually going to leave you number 5 as one of the ones that you have to do on your own. But 4 is good, so let's start with number 4. You have 8 friends. You're going to go to Riverbend for a concert. You're going to sit on that lawn. I've been there. It's interesting. Anyway, you have 8 friends. Only 4 of them can go to the concert with you. Order doesn't matter. Remember, if you're just sitting on the lawn at a concert venue, there's no like official ticket location. Order doesn't matter. It doesn't matter what order you choose your 4 friends in, which is why it is a C problem. It is a combination problem. All right, now if you were to do the blanks, we would say, well, I have 8 friends to choose from for this. As soon as I've chosen a friend, the number of possibilities keeps going down. However, since order doesn't matter, we're going to eliminate the repeats by doing that cheesy thing I call the combination count up. All right, now once you get there, you get the calculator and you get 8 times 7 times 6 times 5, so the top is going to be 1680. And then you divide by 24. So how many different ways can you choose who is going to go? The answer would be 70 different ways. Okay, so just to show you, there you go. All right. Now, if you were using the formula, then that would be considered an 8C4. Because you have 8 different friends that you can't decide about, and you are going to choose 4 of them. So the way it would look, And I'm going to write it out the long way because I want you to see how the formula relates to what I've already taught you. Okay, I want to show you what it actually looks like here. Okay, so the top would be 8 factorial, which is going to be a pretty big number. Now, on your calculator, you could do all that, but again, I want to show you how these are related to each other. 8 minus 4 is 4, so we could just do 4 factorial, but then there's another 4 factorial in the formula. So basically, this works out to 4 factorial, and then this is another 4 factorial that's already there. Now, how does the blank method relate to the formula? Well, take a look. 4 divided by 4 is 1. 3 divided by 3, 2 divided by 2, 1 divided by 1. And what you end up with is exactly what we had over here. So you end up getting 70 ways no matter how you do it. All right. Now, number 5 is one of the problems that I want you to do on your own. Okay, I just want to make sure you know that before we move on here. I don't care which way you do it. You know, we have 2 different methods of combinations. We have with the blanks, or we have with the formula. I don't care which way you do it, but number 5 is one of the ones that I will be checking when I look later. Okay? But I'm going to go to number 6 because I think this is the one that a lot of people, their eyes light up. Like, I did not actually know that that's what's going on with Powerball. I just heard that I could win $1 billion. So I want to throw this one out here because I think it's a really interesting breakdown. So in the Powerball lottery, there is one machine with balls numbered from 1 to 69 from which 5 will be drawn. And then there is a separate machine with red balls numbered from 1 to 26. Now, if you don't believe me, you can actually go to the Powerball website and they tell you all of this. To win, you have to get the correct combination of all 5 balls from the first machine, and you have to pick the correct red ball. How many different combinations can be made? So how many ways can the balls come out? Because if you have the winning ticket, it means you have the correct combination of white balls, and you also got the correct red ball. So what in the world? How can you figure out how many different ways you can win Powerball? Well, you start by saying, well, if I'm going to win Powerball, then the first number that comes out has to be one that's on my ticket. There are 69 possible choices. Hopefully, I have it. Now, as soon as that number comes out, it cannot come out again. So the next ball that comes out is one of 68 possible choices, and then 67, and then 66, and then 65. Now, when it comes to the machine that's full of white balls, I just want to make sure you know, order doesn't actually matter. It doesn't matter what order your choices came out in, as long as you got them, which means this is a crazy but true example of the combination count up. All right, so we're going to get out that calculator, and this is going to be absolutely crazy. Oh, my word. Divided by 1 times 2 times 3 times 4 times 5 is 120, so I'll just put that right there. Okay, so keep that number in mind. 11238 513. So there are 11 million ways that the white balls can come out. But there's a catch. That number is not actually the correct answer to the problem, because there is a separate machine with red balls numbered from 1 to 26, and you have to get that one right as well. So there are 26 more ways that this thing could happen. Oh my word. So what that means is there are 11 million ways that the white balls can come out, but then for each one of those combinations, there's also a matching red ball to go with it. So if you want to know your probability of winning Powerball, you have to actually get the white balls right and the red. So when all is said and done, now you've got to take that number that you had before, and you have to multiply by 26. And that is how you know how many different ways Powerball can come out. It said how many different combinations can be made. Okay, and that would be the answer. So when somebody asks you, what is your probability of winning Powerball, the answer is 1 in 292,201,338. And that is a genuine number. That is the real number here. So you could get, you could go to the store and you could purchase 100 million Powerball tickets, and you would still only have about a 1 in 3 chance of getting the right one. I mean, that's what's crazy about the whole thing. So like I said, I've played the lottery before. I'm not like judging anybody, but the odds are definitely not in your favor. They end up taking about half of the money they generate from the lottery, and they give it to, well, they keep some of it. They give a little bit to education. So, I mean, there are some good things that come out of it, but for the most part, they're taking about half of everybody's money. But that's another conversation for another day. Anyway, so here's what I need from you. I already said do number 5. Number 7 is actually for extra points. There is a catch to that one. I don't want to spoil it for you. I want you to try it. So if you get it, you get, we'll say, 3 extra points on this thing. But the ones that I'm going to require of you are going to be 5, and then these right down here, 9 through 16. Okay? I'm not going to require number 8 because I'm going to make sure we do number 8 together, just so you have no excuses. Now, at this point, some of you might be desperately looking at your calculator. Please, please, please tell me I have that button on my calculator. I don't want to have to do this the long way. If you do, that's fine with me. I'm glad that you're looking and you're learning about your calculator. That's not a bad thing. Anyway, all of these are combinations, which means you have to do the combination count up at the end. So you're still doing blanks. Now, in case you don't remember, the second number is the number of blanks you're making, and the first number is the number that you're starting with. So you end up getting 56 divided by 2, which is 28. Whenever it's written in this format, there's no label. It's just a number. So anyway, so the ones that I'm going to be checking are going to be 5, 9 through 16, and then the bonus, which would be a +3 if you could come up with a way to get it right. It is tricky. If you're having trouble, I would just skip it or save it for later, because it's not going to be for required points. Anyway, I hope this helps get you through the lesson. Thanks for watching. I'll see you next time.